Morning, everyone. So the purpose of the next, I guess, 2 or 3, maybe 4 lectures is to take what you've learned about Python from CISC121 and CISC101 and show you what that looks like in Java. And along the way, I'm going to explain to you what the differences are that you're going to encounter when you use Java as opposed to Python. So the assumption here is that you have taken a Python programming course already. Which may not necessarily be the case if you're a transfer student. Right? So if you're a transfer student, then you must have programmed in either Java before or probably C, or possibly C, sorry, in which case there isn't really much to tell you at this point. Right? So this is really aimed at the people who have only programmed in Python, and now we're going to show you what things look like in Java. Right? So what does a loop look like? What does declaring a variable look like? What does writing what looks like a function look like? All right, so let's begin at the traditional place that every programming course starts at. It's hello world. Right, so you know that in Python, you can write a Python program in as little as 1 line. Right? So if you write that in a .py file somewhere and then run that through your interpreter, right, that will actually print hello world. Right? So a Python program starts running from the first line of some sort of script. That's not the case in Java. Right? So in Java, every Java program starts running from what's called a main method, right? And so it's a method whose name is main, but it's a little bit more than that, right? So the main method here is shown in red, right? Now notice there's a whole bunch of other stuff here as well. So don't worry about all the individual little pieces, right? I'll explain these as we go along, right? So the point for now is that you have to have a main method, right? That main method must belong in a class or something called an interface, but we're not going to get to that for a long time. Right? So it's going to belong in a class, and furthermore, it has to have a very specific form. Right? So that means that when you write your main method, it has to look like public, then the word static, then the word void, then the name main, some round brackets. Inside the round brackets, there's this big S string, ... args. Everything here is important. Right? The case of string is important. The spelling of all the words is important. And then you can write some line of code that will actually attempt to print out hello world. Right? So the very first difference you can see is that Java, even to write a small Java program, it's a lot more writing than it is to write the equivalent Python program. And that's just the nature of the programming language. Right? So there's actually a second form of main that you can use. Right? It's all the same words, so public, static, void, main, big S string. But then after the string, there's some square brackets and then some name here. Right, so you can use either of these 2 forms. They are both equivalent. But one of the 2 must be present if you want your program to run. Right? So if you want it to run as an executable program, it has to have a main method in it. All right, so when you also need a class, because every Java program, basically every programming entity in Java exists inside of a class or something called an interface. Right? So here we've got something that says public and then class and then some name. Right? So that's your class declaration. Right? So in Java, the language itself doesn't care how you spell things. Right? But Java programmers expect you to name things a certain way. Right? So Java programmers expect you to use the standard Java naming conventions. Right? There are no standard Python naming conventions. Right? But Java, there are. Right? So in Java, when you make a class, right, you have to give it a name. Right? And so when you give it a name, the first letter of that name is always capital, or should always be capitalized. Right? So when I create the class hello world, it's big H, hello world. If the name of your class is made up of multiple words, right, you cannot use spaces or hyphens to separate the words. Right? Instead, you capitalize every subsequent word. Right? So hello world, in this case, the W is also capitalized. And that's the way most Java programmers will expect you to write the name of this class. Right? Again, the language doesn't care. So you can run this through your Java compiler if you spell it however you want, as long as there's no unusual characters in the name, and everything will be fine. Right? But other programmers will expect you to spell it this way. Right? And that's the expectation in this class as well. Right? You follow the standard Java naming conventions. Right? So you're allowed to use letters in the name. The first word sorry, the first letter of the name must, sorry, the first character of the name must be a letter. It can be an underscore, but you should avoid that. You are allowed to use underscores in class names and in names in general in Java. Generally, you should avoid that, except in some unusual cases. Right? They are legal, but you should try to avoid them. Right? And you should really avoid the leading underscore in the name. The leading underscore signifies something else to Java programmers. Right? Generally, you should avoid it. Okay, so the other thing you may have noticed is that there are these semicolons flying around at the end of our print statement. Right? So a Java statement ends with a semicolon. That's not exactly true. It's true enough for now. Right? So every significant line of code that comprises a statement ends with a semicolon. That semicolon has to be there, right? Which is very different than the way you were probably taught to program in Python, right? In Python, you can end a line just by pressing enter, right? In Java, that's not true. If you have a statement, it must end with a semicolon. So yeah, so that semicolon there, important. Okay, so, sorry, in this print world, hello world example, we're printing a string, right? So a string is just a sequence of characters. Here you can see that we've got the string hello world, and it's enclosed in double quotes, right? You've seen strings in Python, right? So a Python string, oh, sorry, yes, question.
I had a question there. What's the purpose of putting that calling before the class when you can get the same result without putting a calling?
So, the keyword public here is what's called an access modifier. You don't have these in Python, right? So in Java, the keyword public in front of class means that any other class can see this class. So this class is visible to every other class. For now, that doesn't actually mean anything to you, or probably doesn't mean anything to you if you haven't programmed in Java before, right? If you leave the public off, that means the access modifier of this class is something else, right? And so that means not every other class can see this class. For this particular example, it doesn't matter, right? Because you're just going to run this program anyway, right? So it doesn't matter in this particular case. In other cases, when you start to make a program that's made up of many classes, right, it's going to be important for those other classes to be able to see your other class. So the access modifier in those cases will not be public. You have to pay attention to what the access modifier is on your class. These are all normal questions that you should be asking yourself as you're looking at this, especially if you've come from Python, right? There's a whole bunch of stuff here that doesn't make any sense, right? If you're a Python programmer, and it's just the way it is in Java, right? Every word here has some significant piece of meaning, right? And so when you're teaching the Java programming language to people who've never programmed before, there's often this, well, this is what this means, this is what this means, right? So there's a whole, you just have to get used to the fact that there's all these words flying around. And later on, they will actually all make sense. Okay, so in Python, you can make a string using single quotes, double quotes, triple quotes, and probably many other variations thereof, right? So these are all valid strings, right? Single quote, hello world, double quote, I don't know how to say that, I'm not Danish, right? Triple single quotes, I'm not South African either, so I can't pronounce that, right? And so those are all valid strings in Python. So these are what are called string literals. Right? A literal is just a value that you can write down. Right? So I can write down the string hello world. Right? And so in Python, string literals are denoted by single, double, or triple quotes, triple single quotes. You can also use triple double quotes, I'm pretty sure. Right? You can't do that in Java. In Java, you can only use double quotes if you want a string. Right? So here, we've got the string hello world. Notice that there's another word here that has appeared that's different than Python. I'll explain that in a minute. Right? If you want to write down a string, a literal string in Java, it must be double quoted. Okay, so in Python, our hello world program uses the print function. Right? Python's print function is really actually kind of cool from a programming perspective. So you can print out a whole bunch of things using Python's print function. Right? So I can do 2, comma, some string, comma, 3, comma, some string, comma, 5. Right, and that prints out 2 plus 3 equals 5. Right? If you know a little bit more about the print function, you know that you can change the separator and so on and so on and so forth. Right? So Python's print function is very flexible. Right? Okay, Java's print function, less flexible. So it turns out that the equivalent function in Java is this thing called system dot out dot print ln. That's an L, not a 1. Right? Again, notice that's a lot more verbose than the equivalent Python. Right? You got to write a lot of stuff just to print something in Java. Right? There's only one argument inside the round brackets for Java's print function. Right? So if you want to print out the string 2 plus 3 equals 5, and you want to make it by joining a bunch of other stuff together, you have to use the plus or the concatenation operator here. Right? So this line of code here says takes the integer value 2, right? Then we've got the plus sign, we've got a string, right? Plus sign, then the 3, then a plus sign, then equals, then a plus sign, and 5. Right? And so what this does in Java is it looks at the 2 and it looks at 2 and the string plus. Right? The compiler says, oh, you want me to take a 2, the number 2 and the string plus and join those together. So that's going to make the string 2 space plus space. Right? That produces a string. Right? And then it sees the plus 3 and it says, oh, you got a string plus something, so you want me to make a string. Right? So it tacks the 3 on to the end of the string. Right? Then adds the space equals space to the end of that string, then adds the 5 to the end of the preceding string. Right? So all this stuff in brackets computes a string, which you can then print. Right? If you play around with the print line, you'll quickly realize that you can print stuff like just the number 2 or just the number 1.5 or things like that. Those also work. Right? But in this example here, we need to make a string that's equal to the one that we want to print, right? So you can't use commas like the way you can with Python's print function. All right, so here we've got this, again, some Python where we're using a variable s, right? So on the first line of the program, I've got s gets assigned the value some string. On the very next line of the program, you can write s gets the value some integer. Right? On the next line of the program, you can write s gets the value, and that's some list. Right? So Python variables have no type. Right? There's nothing. The program. So Python stores no information about the type of s. Right? Or another. Sorry, the type of s is unimportant to Python. Right? The variable itself, the thing called s, right, has no type bound to it. The thing on the right-hand side has a type. Right? That's a string. That's an int. That's a list. Right? But the thing on the left-hand side of the assignment statement has no type. That's not the case in Java. Right? So in Java, your variables actually have types. Right? So if I want to store, if I want to store what looks like the string hello world in a variable s, right? Before I do that, I have to tell Java that this thing s is going to store a string. Right? So I'm declaring the variable s for the first time. So this is for the first time you use it in a method, so a function. So the first time you use it in a function somewhere, right? I have to, if I want to make a variable s that stores a string, right? I have to create the variable s and I have to tell it that it's a string. So big S string in this case. Right? So string s says that there's a variable called s. The type of the variable is of type string. Right? I can now use s to store a string, a reference to a string object in it. And I'll explain that in just a second. Right. On the next line, I've got the number 123 that I want to store in a variable. I cannot reuse the name s. Right? So I can't, on the very next line, write int s equals 123. That doesn't work. Right? So I can't redeclare a variable immediately after declaring it the first time. Right? There's more to it than that, but for now, I'll just leave it at that. Right? So I have to create a different variable now. Right? So it has to have a different name. So I can make a variable t to hold the number 123, and I have to tell Java that the type of t is int. Right? So the variable t can hold values whose types are ints. If I want a list that's the same as the one I just showed you, right, it's a lot more complicated. Right? So again, I can't reuse the name s. I can't reuse the name t. So I have to make a new variable. So I'm going to call it a list. Right? The variable has a type. Now the type of list in Java is complicated. Well, it's complicated at this point in time. Once you get used to using it, it's not so hard. Right? But the list type in Java is called big L list. Right? And not only do you have to say that it's a list, but you have to say what kinds of elements are in the list. And that's another big difference between Java and Python. Right? A Python list, you can throw whatever you want into the list. Right? I can put in a string, then an integer, then a floating point number, and then another list, and whatever I want. It doesn't work that way in Java. Right? In Java, I can make a list that holds integers. I can make a list that holds strings. Right? I can make a list that holds other lists, but for the time being, I can't make a list that holds all of those things at the same time. Again, if you've done any significant programming in Java, you know that's not quite true. Right? But for now, that's the case. Right? So it's list, less than, integer, greater than. Right? So the triangular brackets indicate the type of element that's held in the list. Right? And now I need to make the list. So there are no list literals in Java. There's a list literal in Python. Right? So if I want to write down a list, I can just write square brackets, elements that are in the list, and away it goes. Can't do that in Java. So in Java, there is no list literal. Right? Instead, what you have to do is you have to write something like new array list, angled brackets, round brackets. Right? And then you have to put the numbers 1, 2, 3 into the list. Right? And so I have to write something like a list.add1, a list.add2, a list.add3. Right? If that doesn't make any sense to you, don't worry about it. We'll explain all of this when you get to the list part of the course. Right? For now, I'm just showing you there are some big differences between Python and Java. Right? So the important part on this slide is that Java variables have a type. Right? When you first declare the variable, you also specify the type. You cannot change the type of a variable. Right? So there's no way for me to transform s from string to something else. Right? And variables can only hold values of the declared type. So s can only hold a string, t can only hold an int, a list can only hold a list of integer. All right, so when you're naming your Java variables, there's also a naming convention. So the convention in Java is that a variable name always begins with a lowercase letter. Right? So lowercase s, lowercase t, lowercase a, and then big L list. Right? So the first letter of a Java variable name should always begin with a letter. You're not allowed to use spaces in a variable name. You can use underscores, but they are discouraged in Java. They're legal, but not common. If you have a multi-word variable name, you use what's called lower camel case. Right? So the first letter of the name is in lowercase. Every subsequent word in the name is in starts with an uppercase letter. Right? So that's why it's A, then big L list. Right? And that's just the convention that Java programmers use. If you deviate from this convention, it will slightly confuse most Java programmers. Right? It becomes harder to read a typical Java program for Java programmers. Okay, so what about comments? You can have comments in both languages, right? So in Python, your only comment is the line-ending comment that starts with a pound sign or hashtag. Right? So hashtag something, and that hashtag or pound sign, that at the end of that line, that ends the line of code. Right? So it's called a line-ending comment. I've got some variable p, its value is 100. Right? This is going to be a compound interest rate example. Right? If you don't know what compound interest is, don't worry about it, it's fine. Right? This is just showing you some math. Right? I can compute the annual interest rate in percent is 1.25%. Right? I can compute the final value after 10 years using this little formula here. Right? So that's just p times 1 plus r raised to the power 10. And notice that you can put the comment at the after the calculation here, and that's just fine. Right? That signifies ignore everything up to the end of the line. You may have been told that you can use the triple quoted string as a multi-line comment. That's not true in Python. In many cases, it gives you the effect of using a comment, but you can write invalid code doing it that way. So you have to be a little bit careful about using the triple comment string. It's commonly done in Python to use a triple commented string, a triple quoted string as a multi-line comment. It technically doesn't work. It won't always work. Okay, so if you want a line-ending comment in Java, that starts with the double forward slash. Right? So // is the equivalent of the hashtag in Java in Python. Right? So the exact same code in Java, It looks like follows, right? So there's my comment. T is the value 100. It has the type double, which I'll explain shortly, right? I've got a variable r. I have to give it a type, so it's also double, right? The final value, it also has a type. It's double, right? Again, the line ending comment starts with the double slash. Also notice that there's, when I compute 1 plus r to the power 10, I can't use star star. That doesn't work. Okay, Java does have a true multi-line comment, right? So a multi-line comment starts with slash star, right? No space between the slash and the star, right? It ends with star slash, right? So as soon as you write slash star, Java thinks that you're writing a multi-line comment. It's going to look for the next matching star slash to end the comment, right? So there's the start of the comment and there's the end of the comment, right? The multi-line comment you can insert into the middle of some statement and everything's fine, right? So what Java does is it ignores everything between here and here, right? So I can insert one of these comments like that into a line of code. Java just ignores all of that and continues with the rest of the statement on the next line, right? So that's fine, right? You can't do this sort of thing. In Python, there's no way to do this sort of thing, right? But you can do this in Java. Generally, you shouldn't do this because, it makes it hard to read your code if you do this, but it is legal. All right, so notice there's no exponentiation operator, right? So you can't write star star in Java. It doesn't mean anything to the programming language. If you want to compute an exponent or a power, you have to call this method math.pow, right? Big M math, period has to be here, little p pow, right? So math.pow, that's the base. That's the exponent. Okay. So 1 plus r raised to the power 10. All right, so we're talking about types, because that's the important part for now. So in Python, entities do have types. Right? Your variables don't have types, but the things that the variables refer to, they all have types. Right? So when you write tf gets the value big T true, right? That thing, big T true, is a Boolean or logical value in Python. Right? If you write the number 1, right, that's an int in Python. If you write the number 1.0, that is not a double in Python, that's float. Right? So if you write the number 1.0 or anything with a decimal in it, you end up with what's called a float. That's a string, right? Square brackets, that's a list. There's other literals in Python as well, right? You have dictionaries, tuples, and other things as well. Okay, so what are the equivalent types in Java? Right? So if you want a Boolean type in Java, that's Boolean, right? Boolean or logical, whatever you were taught it was called. That's little b Boolean, right? If you want an int, an integer type in Java, that's little I int. If you want what corresponds to a Python float, that's double in Java. If you want a string, that's big S string. And if you want a list, that's big L list, and then some type inside the angled brackets. Right? No list literals in Java. Right? All right, so in Python, hopefully you learned this in 121. Everything is what's called a reference type. Right? And so in Python, all values are actually what are called references to objects. So did they explain what a reference is to you in Python? Yes? No? No? I'm guessing no. Okay, so I'll explain what that is in just a minute. Right? So in Python, everything's a reference whether you know it or not. Right? Java also has these same kinds of types, right? These reference types. So if you see any type that begins with a capital letter, like big S string, big L list, big A array list, right? These types are all reference types, right? And so that's why the naming convention is here, right? It's because if you just look at a name and you look at the way it's spelled, you can actually tell whether or not it's a reference type, right? If it begins with a capital letter, it's a reference type, right? Now we made a class, right? So we made this class called Hello World. Whenever you create a class, you create a new reference type. Right? So this is Java's mechanism of making user-defined types. right? And that's why you should name, when you name your classes, they should always begin with a capital letter, right? Because all classes are of reference type. That is the way Java works. Now, coming from Python, it's a bit confusing because Java has a second kind of type. It has a primitive type. So anything that begins with a lowercase letter is a primitive type, right? So Boolean, little b, primitive. Int, little I, primitive. D, little double, double little d is a primitive type. Big S string, reference type. Big L list, reference type, right? Now, you can name your class whatever you want. So you can give your class, you can start your class name with a lowercase letter, and now people think that, well, at first glance, it looks like your type is now a primitive type, right? Which you can't actually do, right? But that's why the naming convention is here. I'm just looking to see if there's a slide that actually explains the difference between primitive and reference type. Okay, so I have to explain what a primitive type and a reference type is. All right, so in Python, if you write the number something like x equals 2, right, like that, what you're saying is you want a variable whose name is x, right? You want the number 2, right? And what this looks like to most people is that x stores the value 2, right? That's not what happens in Python. So in Python, that 2 is actually an object of type int. All right, so what's an object? So an object is just a chunk of data. Sorry, an object is something that has some data, and it has some methods that you can call using that data. Right, so when you add two numbers, when you add two ints, for example, you're actually calling a Python method of some kind, right? Which for our purposes is a function. Right, so what does this look like in memory? Right, so if you imagine computer memory. Okay, so here's my picture, here's my very quick picture of computer memory. So computer memory is just a bunch of ones and zeros, right? So I can imagine that memory is just a big array, or sorry, a big list for you guys. Right? So here's row 0 of memory, here's row 1, here's row 2, and so on. Right? So in other words, every memory location has a unique number bound to it. Right? So this is value, associated value whose, I guess, index is 0. Right? That's a value whose index is 1. That's a value index is 2. Right? So it's just a big list. Right? So when you write something like x equals 2, you need to put the variable x in memory somewhere. Right? So I'm just going to stick it, I don't know, I'm going to put it here. It doesn't matter, oops, sorry, it doesn't matter where you put it. Right? But the variable x appears in memory. Right? Because that's what you're saying, right? I want a variable, so I want something that can hold a value. Right? It has to be somewhere in memory. So somewhere in memory, this thing called x appears. Right? Now, what value goes here? Right? It's not the number 2. Right? Not the int 2. That's not how it works in Python. Right? So the value 2 is not actually stored in memory here. Right? Instead, what happens is somewhere else in memory. So somewhere else in memory, when you write that line of code, there's an object whose type is int. That appears somewhere in memory. Okay, so I'm going to say this is line 107. It's arbitrary. It doesn't matter what it is, right? So somewhere in memory, the line, an int object appears in memory, right? Inside that int object, there's this value 2. So this int object actually spans many lines of memory, right? Part of that is the number 2. Other stuff, I don't know what the other stuff is. Right? You'd have to look at the implementation of the Python programming language to figure out what the other stuff is. Right? But there's an int object that appears, its value is 2. Right? And the value that's stored in the x, conceptually, it's the number 107. So not the value 2. Right? It's the memory address 107. Right? So it's the address of the object that represents the value 2. Right? I'm calling it the memory address, but that's not necessarily how it has to work. Right? That value that's stored there is called a reference. Right? It's a reference, or it's a way to get to the object whose value you want. Right? It's not the number 2 itself. So that's what a reference is. Right? So for our purposes, a reference is just a memory address. Right? It tells you, how do I get to the object of interest? It's not the object itself. So when someone says, you've got a reference variable, right? So in Python, everything is all variables are reference variables. That's what they mean, right? The value that's stored in memory, or the value that's bound to the variable, is a reference to an object. So in Java, the exact same thing is true. If you make a string in Java, right? String s equals hello world, right? You get a variable s. You get a string object that represents the string hello world. The value that's stored in s is a reference to that object that represents hello world. Okay, and you might wonder why you do it this way, right? Why does all this? Why is it stored? Why does it work this way and not some other way? Right. So in this example here, it's natural to ask, well, why don't we just store the value 2 beside x? That seems a lot easier, right? And so in Java, that's exactly what happens, right? For these primitive types, Java actually stores just the value, right? So if you write int x equals 2, then the value 2 gets assigned to x, right? So there's no reference to the variable to an object whose value is 2 in Java. Right? But in Python, everything is a reference. Java splits these things up. Right? Simple stuff are typically primitives. More complicated things are typically references. Right? And so you have 8 of these primitive types in Java. Right? So we've got Boolean, that's true, false. Right? Notice that there's a whole bunch of integer types. Right? There's byte, char, short, int, and long. Right? For our purposes, int, long, and char are the only ones that are relevant. Right? I'll explain what the differences are between all these in a moment. For your floating point types, you have 2. You've got float and double. Right? So these represent numbers that are not integers. Right? You have 2 different types. Right? And so those are your 8 primitive types. Right? If you have a reference of type Boolean, then what gets stored in memory is either true or false. Right? For these integer types, what gets stored in memory is the value of the integer. And for the floating point types, what gets stored in memory is the value of the floating point number. Right? It's not a reference type like it is in Python. Right? In Python, everything's reference type. Okay, so here's, I guess this slide doesn't really explain what a reference type is, but when you write x equals 1 in Python, you get a reference to an int object. Right? When you write y equals 1.0, you get a reference to a float object. And when you write s equals the string hello, you get a reference to a string object, str object in Python. Whereas with primitive types, they actually store the value. So in Java, int x equals 1 means make a variable x and stick the value 1 beside it. Right? Double y equals 1.0, make a variable y, stick the value 1.0 beside it. Reference type, big S string, right? Make a string object hello, store a reference to that string object beside S. Right? Don't store the object itself. Okay, so when I draw that memory diagram there, each one of those boxes, they can only hold one value. Right? So I can put in basically one number or something in there. Right? So all of the primitive types occupy a defined fixed amount of memory in Java, right? So the Java programming language says an int occupies exactly 4 bytes, 32 bits of memory, right? All of the different primitive types occupy some different amount of memory, right? But the amount of memory is fixed, right? And that's the implication of writing down if storing the value 2 beside x, that's the implication, right? That box in memory has a finite size, right? It's fixed, right? And so that has all sorts of implications, right? So if I have a finite amount of memory in which I can store a value, right? Suddenly you get all these implications, right? So for example, the int value, the int type occupies a fixed finite amount of memory, and what does that mean? It means it has a finite number of possible values that it can take on, right? There has to be some smallest int value. There has to be some greatest int value. That's not how it works in Python, right? So in Python, you can make an int object, and you can calculate whatever int you want up to the limits of computer memory, right? So you can compute, for example, 10 to the power 100, right? 1 Google in Python, and it works just fine. That doesn't work in Java because there's some smallest int value and there's some greatest int value, and 1 Google is much bigger than the greatest int value, right? So when you go to use int, there's all sorts of things you now have to worry about in Java, right? So int is your usual choice of integer programming variable, right? It's the one you default to because it's normally sufficient for most programming problems. Question? Okay. So I've got the variable low and I've got the variable high, and I'm going to store the smallest or the most negative integer value in low. I'm going to store the greatest or the greatest integer value in high, right? The name of the most negative value and the name of the most positive value, big I integer dot, all caps min value, big I integer dot, all caps max value, right? Here's one of the exceptions to using an underscore in a name, right? If you're writing out a name that's in all caps, right, then there's no way I can distinguish spaces between words except to use the underscore, right? Anything in all caps is indicating to you that it's a constant, right? So you can't change the value min value, and the programmer can't change the value of max value, right? If you actually print out the numbers, you get the following numbers. That's roughly minus 2 billion and roughly 2 billion, positive 2 billion, right? So if you're using int as your type, you can't compute a value that's less than that, and you can't compute a value that's greater than that, right? Which is very different than the way Python works. Right? Python doesn't have this limitation. The reason it doesn't have this limitation is because it stores a reference to an object, right? It doesn't store the value itself. So the int object in Python, it can do all sorts of magic to compute values that are outside the range of Java's int. Okay, so when you write down a number in Java, a number with no decimal points in it, right, like -1, that's an int literal. Right? So any number written without a decimal, not ending in big L or little l, is an int literal. If it ends in a big L or a little l, that becomes a long literal. Right? I'll explain what the difference is between int and long short in a bit. If you try to write down a number that's less than that or greater than that, right? So you write down an int literal that's less than min value or greater than max value, and you try to assign that to an int. If you just write that down, it becomes a compile time error, right? So when you go to try to run your program, which actually involves a bunch of other steps, the thing that reads your program will tell you, hey, that's not a valid int, right? And it won't, your program won't run. So here, -1 is an int. There's 99, 98, 1, and 0, right? You have all the usual arithmetic operators except for exponentiation. Right? So addition, subtraction, multiplication, division, parentheses, they all work. Right? No exponentiation. Right? If you're writing out a long literal, you are allowed to use the underscore to make it easier to read. Right? So 1 underscore 000 underscore 00 is legal. It's also a little bit uncommon, but it's legal. Right? If you know what binary, octal, and hexadecimal are, you can write those down as well, but they're not important to us. Right? If you're interested in how to do this, just look it up on the internet. Okay, so here's another weird thing with another big difference between Java and Python. So when you do arithmetic in Java, you have to pay close attention to the arguments that are in your expression. Right? So an arithmetic operation involving two int values, whoa, how did I do that? Always produces an int value. So that's the rule. Right? If I take two ints and do something with them, some sort of arithmetic operation with them, I always get back an int. Right? Which is weird if you divide. Right? So if I divide two ints, in most cases in math, it's not an integer value. Right? But in Java, you get back an integer value. So I'll explain what happens there in just a second. So here I've got 1, 3, and 13. Right? I have a variable called result. It's the sum of 1 and 3. So that's 4. Right? X minus y, x times y. Okay, now what about x divided by y? So I've got 1 divided by 3. So the way this works in Java is you compute 1 divided by 3 the way you would normally compute it mathematically. So you get 0.333333. Throw away everything after the decimal point. So you get 0. Right? That's not how it works in Python. Right? Python, if you write 1 divided by 3, you get back the float value, 0.333333. Right? Why does that happen? Because everything in Python's a reference, so the objects can do all sorts of magic and give you back the right answer. Right? In Java, the values here are all primitive. So we store the value 1, we store the value 3. When you do divide, what probably ends up happening is you ask the CPU to divide the number 1 by the number 3. Right? The integer value 1 divided by the integer value 3. The CPU does this integer arithmetic for you. You get the value 0. Z divided by y is 13 divided by 3. So that's 4 point something. Right? 4.33333. Throw away the 0.33333, you get back 4. Right? The exact same thing happens with negative numbers. Right? So negative 13 divided by 3, negative 4.33333, throw away the 0.333, and you get negative 4. Right? So Java uses what's called truncating integer division. Right? You just toss away everything after the decimal point. Right? And of course, you can use parentheses if you need to specify the order of operations. Right? So if I want to compute the average of x, y, and z, right, I have to compute the sum, right? But the division has higher precedence than addition, right? So I have to make sure that the sum happens before computing the quotient. Right? So all the rules that you learned in grade school about a mathematical precedence, they apply in Java as well. Yes? Sorry? Okay. All right, so what happens if you have two int values and you do some arithmetic operation on them? The language says you always get back an int value. So what happens if you do an operation and the value exceeds integer max value? Right, or is less than integer min value. Right? So what happens in Java is it just wraps around. So here we've got integer max value. Right? So that's x. Right? For y, I'm going to write x plus 1. Right? So that tries to compute integer max value plus 1. Right? But integer max value is the largest integer value. So when you add 1 to it, what happens is you wrap around to the other end of the range. Right? And so if you draw out the number line corresponding to the integer values, so here's integer min value. And here's integer max value. Right? So if you go past this point, you take the value and you wrap it around to that point there. Right? So when I add 1 to integer max value, I come around and end up at integer min value. If I add 2 to this, right? Well, adding 1 takes me to here. So now adding 1 to this takes me to integer min value plus 1, right? So the second most negative value, right? Integer max value plus 3. So plus 1 takes me to here. plus 1, plus 1. So you end up with integer min value plus 2, and so on, and so on, and so forth. Right? Again, that's not at all how it works in Python, right? Python, if you did this, if you wrote code equivalent to this, you would just get back the value you would expect mathematically. So the same thing happens if you compute two values and the result ends up being less than min value. So if I start at min value and subtract 1, well, it just wraps around. Right? So starting at min value, if I subtract 1, it comes around and goes back to your max value. Right? If I subtract 2, right, that goes to max value, and then you subtract 1. So that becomes integer max value minus 1. Right? And x minus 3 is integer max value minus 2. Right? And so what does this mean? It means you can start out with a negative number, subtract something from the negative number, and end up with a positive number. Right? Or subtract a small number from the negative number and end up with a positive number. Right? Which doesn't make sense mathematically, but that's the consequence in Java. Right? Why did it all happen? Because we're using a fixed amount of memory to store the values. Right? Notice that you don't get an error. Right? There's no error. If you run the program, it runs just fine. Right? So this happens silently. Right? You have no real way of knowing that this has happened, other than that something weird has happened. Right? You sometimes see this in video games. Right? A lot of video games, there's an upper limit on some value. And you can, if you exceed that upper limit somehow, then the value wraps around to the other end. Right? And so that's not an infrequent bug in many video games. Okay, so this phenomenon is called integer overflow. It actually has a name. Can I click them? The links? You can click them in your own time. I'm not going to go through all of them right now. So integer overflow occurs when an arithmetic calculation with an integer type results in a value that is outside the range it can represent. Right? So in Java, wrapping happens. Right? But other programming languages will handle what happens differently. Right? Python, nothing happens because because there's no upper or lower limit. Right? Some programming languages will stop or will indicate back that there's something has happened, something unusual has happened. Right? Java is not one of those languages. Right? So wrapping happens silently, you're stuck with the result. Right? This phenomenon of integer overflow has resulted or has been part of the cause of many infamous and in some cases unfortunate events. Right? Ariane 5, a lot of these happened before your time, unfortunately. Ariane 5, that's the European Space Agency, that's its current generation of rocket. The first launch of it failed, so they launched this rocket, had 2 or 3 satellites on it, and shortly after launch, it ended up crashing. One of the reasons it ended up crashing, integer overflow. Deep Impact was during your time, so you should have been born during this time. Deep Impact was a satellite sent to an asteroid by NASA. The first collision with the asteroid was so it launched something at the asteroid. That was successful. They tried it a few more times. In 2013, they tried it and they realized and they lost contact with the spacecraft. What happened? Integer overflow. That's one of the many reasons. Therac 25 is a very sad story. It's also a sad Canadian story. So Therac 25 was a radiation therapy device. So it's a medical device that was used to dose patients with radiation, probably to treat cancer or some other illness. It ended up killing several people. 3? I can't remember. A small number of people, but it ended up overdosing more. One of the reasons this happened this happened is because, again, of integer overflow. Right? There's many other reasons as well, but one of the reasons it happened was integer overflow. Yes? You want to what? Okay. All right. All your GPS systems, they have to deal with this internally because all your GPS systems, there's an integer overflow issue that happens inside of them. Every 2 weeks, something special has to happen. Right? Year 2000, you missed that, I think most of you. But you should be here for year 2038. And so there's going to be another big problem in the year 2038 with the way that time is recorded on many computers. Right? So the way that time is represented on many computers is the number of seconds after January 1, 1970. I don't remember. So I don't remember which time zone. Right. So it's the number of seconds after from January 1st, 1970. Typically, that's stored in a integer variable, a 32-bit variable. Yeah. If you count the number of seconds since then, right, it's going to hit the maximum integer value in the year 2038, and then suddenly the time on all of your computers will go negative, or will go back to 1970. Sorry, January 1, 1970. So there's a big problem there that software engineers are currently trying to solve, or not trying to solve. All right, so that's enough for today. We'll pick this up on Monday, I guess.